Now let's take a look at the Smith chart and how we use that to plot the reflection coefficient. On the Smith chart, we're going to plot the reflection coefficient in its polar form, which means it has a magnitude and a phase. Let's take a look at the various places that we're going to be examining for the reflection coefficient. I want you to notice right here, there's a little wording that says angle of the reflection coefficient in degrees. When we read this axis right here, that's the axis that tells us the polar degrees, the polar angle of the reflection coefficient. So let's look and see if that's consistent with what we had seen in our previous example before we actually included the Smith chart. So let's take a look. Let's suppose that we wanted to plot a magnitude of 1. I'm going to come right out here to the edge. There's my magnitude of 1. That should be magnitude of 1 with a phase of 0 degrees. Let's see if we can read that. Well, it's hard to see right here, but if I use that center point, see how it's plus 20 there and it's minus 20 over here? Well, in between, that would be 0. So here's 1 at an angle of 0. Let's look at our angle of 45 degrees here. Here's the angle of the reflection coefficient at 20, 30, 40, 50. Right there is an angle of 45 degrees. So if I wanted to plot my reflection coefficient with an angle of 45 degrees, I would take a straight edge or a piece of folded paper and I would simply draw a line like this between the center of the Smith chart and the outside of the Smith chart at 45 degrees. Now let's talk so that's how we find the angle. That's by reading the yellow circle around the outside. Now let's talk about how to find its magnitude, and let me show you where that is. Right down here is a little axis that says the reflection coefficient of E or I. That is also the reflection coefficient of the voltage. And that's what I'm going to be able to read in order to tell me the magnitude of the reflection coefficient. So let's check right out here. Let's check our value where we know that the magnitude should be 1 with a phase of 0 degrees. I'm going to take my piece of paper and I'm going to mark these 2 points because that's showing me the magnitude of the reflection coefficient. So I'm going to mark that on my piece of paper or my straight edge, and then I'm going to bring it down here. I'm going to start it here at the center, see right there, and I'm going to come over to where my mark is, right there at 1. So the magnitude of this reflection coefficient, when I read it right there, is 1. What would have happened if I had had my reflection coefficient right here? Let's mark that one. See, mark right here at the center, mark right there on your piece of paper, and then bring it down to the reflection coefficient axis. Start at the center, always start here at the center, and come out to this point. In this case, the magnitude of the reflection coefficient is 0.3. I can read that number right there. Now let's go back to our other case, where I was centered here on the line, centered here up on the imaginary part. My reflection coefficient is right here. Let's see what that is. Take my straight edge, my paper, same thing, mark from the center out to the point that I'm interested in, bring it down to the reflection coefficient axis, mark first at the center and then at the next point. That would have a reflection coefficient magnitude of 0.6. So this is how I find the reflection coefficient. Now let's look at the